So today we're going to be talking about business logic flaws in this applied review episode. So without any further ado, let's just go ahead and start talking about it. These refer to flaws in implementation of an application that might let an attackers produce unintended behavior. So it's kind of a vague definition. So it's just any kind of unintended behavior that allows attackers to maybe manipulate other parts of an application for either information gathering or malicious purposes. Um, and these things aren't typically found in normal circumstances. They only really reveal themselves when an attacker tries to get these flaws to be exploited. Um, so this could be sometimes it's domain specific, but in the context of business logic flaws, it's some kind of flaw that relates to a business rule. So a business rule might be, like payment information or the purpose of an application is more over the, underlying theme here. But these are introduced in a variety of different ways. One of which is, if your developers make poor assumptions about how users are going to be interacting with the application, that could lead to just bad validation of user input. If you rely on, weak controls or you trust the controls the user has, so like, if I'm interacting with your application in a web browser and you hide a parameter, don't assume that I won't be able to manipulate anything on the client side, because I will be able to at some point. Um, and one of the other times you'll see this is when developers are working on incredibly complicated applications that have, maybe they work in with different applications and maybe there's a bunch of different libraries that developers don't totally understand, or maybe the code is just really difficult to interpret. Those things could lead to these kind of problems because they might assume that, something is fixed somewhere else, or they don't have to sanitize this because it's sanitized there. So those are kind of the ways that these vulnerabilities get introduced. But let's go ahead and talk about what the potential impact could be. And as a lot of these vulnerabilities tend to be, or these broader categories, it really depends on what kind of functionality is being manipulated. Gaining access to special data or bypassing authentication is obviously a big deal, but I also, an attacker might benefit indirectly depending on what that information is. So if I gain information about, dependencies that are being used for software, or I just gain information about how an administrator is enrolled in the program, that could be really useful information for me, and I might get a lot of benefit out of it. So the impact obviously varies a good deal with this one. But let's talk about, examples or, greater categories of these things. So excessive trust in client-side controls basically just refers to, as a developer, you shouldn't assume that users will only interact with the web application through the interface that you've provided, right? Assume that I'm going to put everything in a proxy and that I'm going to tamper with every single, parameter that's being passed, because odds are that will happen. So just try not to assume what kind of capability the user has to manipulate data. The other thing might be poor handling of unconventional inputs, which is kind of vague, but basically it's if you have, let's say I'm buying something in a store and I can specify the quantity, but the application doesn't check if there's enough stock to fulfill that quantity, or if there's a fulfillment center, that has it within my region, things like that. So verifying those different numbers, I shouldn't be able to add 10 million of an item into my stock or into my cart in a shopping application, things like that. So, when you're looking for poor handling of inputs, try to just think of like, okay, well, what limits are being imposed on this data? How many characters, what kind of characters can I put in? And what happens when I reach those limits? Is it an error message that says I can't have that many, or does just nothing happen and it just fails to make a change? Or maybe there's a verbose error message that reveals information. And then also think about what kind of transformation is being performed on your input. Is it being encoded? Is it being encrypted? Those kind of things. When we move on to unexpected user behavior here, this has a few subcategories that are important to talk about. One of them is going to be, if you trust your users too much, you might assume that an authenticated user is already going to be trusted, or that, you might over provision certain things. For example, right, if an application is restricting roles based on like the admin username or the root username, that could prove to be really problematic if a user is able to change their username or their email to fit one of those things. So, if you trust the user inputs or user-controlled things, that might be a bit of a red flag, and you should really verify those things. Mandatory inputs are just, if, let's say, I'm shopping on a site and there's a mandatory input for my shipping address, but I can modify that request and not include it. I shouldn't be able to submit an order without a shipping address, right? Because then all those orders are going to get to your fulfillment center or your shipping area or whatever, and they're going to have a bunch of orders with no shipping address, and that could really clog up your workflow and basically lose you a day's work and a bunch of potential orders that could have been fulfilled. So making sure that that business rule is being enforced. And then the other thing is, breaking the sequence, or, assuming that users are going to follow the sequence of events. We talked about this a little bit when we talked about authentication, which was, if you skip certain, steps of a two-factor authentication event, you might be able to bypass it entirely, which is a big problem. Don't assume that the user will add something to their cart and then go to checkout and then go to the intended sequence. Assume, maybe they access the checkout endpoint, after they add something to their cart, but before they, maybe they apply a coupon as they're checking out or something like that. And as we talk about coupons, we go over like domain specific. These just have to do with like domain specific is just kind of, like the special ones or ones that are context specific, extremely so. So, think of like a website that gives you a discount if you spend like, if you have 3 items in your cart, and you use this coupon code, you get 30% off your order. That might be fine if you verify that, the 3 items are in the cart, then you can apply the coupon code. But if I remove those items after applying the code, I shouldn't still get the 30%. Discount on some other item I throw in my cart later. So it's those kind of, don't assume things about how the application is going to work. Make sure you're verifying every step of the way. And then dangerous encryption is just, make sure that user controllable input that is encrypted is not really like made available to the user. You might call this like an encryption oracle, where, if us as attackers, right, can see what that arbitrary data being encrypted looks like afterward, we might be able to figure out aspects about that encryption. And if we can figure out how to encrypt data the same way, we might be able to send it to, the back end of an application where it's processed and cause some real damage to it, or at least, be able to pass off data as if it came from the application, which could be a big issue. So let's just go over one of these examples here with excessive trust in client-side controls in this Hack the Box machine I picked out called Academy. So we'll jump into that, and then we'll be right back to talk about prevention. All right, so we're here with the Academy machine from Hack the Box. I've already got it booted up, and there's a domain you've got to add to your host file called academy.htb. If you go ahead and do some directory enumeration, you'll find that there is a endpoint called admin.php. There's a couple other ones, but admin is the one that we want to gain access to, right? Because it sounds like an admin portal. And if we try to access it, it prompts us to log in, and using common credentials like root, right, it's not going to work for us. You could try some of those, you could even brute force some, but we're not going to be super successful with it. So what we can do is actually go ahead and try and register an account. So I'm just going to say Gabe CTF. I'm just going to say password for my passwords. I'm going to enable my proxy, and then I'm going to make sure that Intercept is turned on in Burp Suite. I'm going to click register. And then you'll notice that we get this post request for registration. And of the parameters that we saw in this input form, right, it was username, password, and the repeated password, which makes sense. Let me go ahead and throw this on my repeater, which makes sense, right, because we have the user ID, password, and a confirmed password. But we also have this other parameter that we didn't notice when we filled it out, and it's the role ID, which is 0. And sometimes applications will have like a role or an admin role. It might be admin or default or something. But we could try switching this role ID to something like 1 and sending this request. You'll notice it gives us a 302, so it's going to redirect us somewhere. And it looks like it gave us a success page. We can even render it, and you'll see that it lets us log in just fine. That being said, let's go ahead and disable our proxy and see if it lets us log in. So we'll go to the admin page. And you'll notice it lets us log in as an admin. It also lets us do the regular login as well. If I think I go login.php. It lets us log into, like the fake like Academy environment that other users are supposed to be able to access, but it also lets us log into this admin page that we probably shouldn't have access to. So that's just something to keep in mind. The way that this works, right, is it shouldn't be, let me go back a couple. So the application is placing too much trust in the fact that we're going to only use a browser to submit this data. If this was in the URL, it might be, even easier to mess with. But even so, it's just one of the post parameters, and we can modify this as much as we want. Um, so it's just another example of not trusting your user inputs, or not so much your user inputs, but assuming that the user is only going to use the technology that you allow them to use. So just keep that in mind when you're doing your tests, and we'll go ahead and jump back into prevention. All right, so now that we've finished that machine, let's just go over some prevention methodology type stuff. Obviously, right, make sure that your developers and your testers understand the domain and the business rules that they're trying to enforce, so that you kind of avoid these things. Also, try to avoid making assumptions about the user behavior and, uh, assumptions about other parts of the application. If you are, making a big complicated web application about shopping, don't assume that the authentication team or the guys that work on authentication handle everything with it. Maybe you should, take a look at the source code and look around and make sure that you aren't just assuming too many things about that other end of the application that you're messing with or making calls to. Also, to avoid, overly complicated programs, try to maintain clear design documentation so that new developers that are onboarded to a project, or just even developers starting to make changes to it, actually understand those data flows, or at least the way that the application works. So as long as your documentation is clear, that works fine. And the same thing, writing clear code that's easy to read and avoids logic flaws. So if you have code that's easy to read, odds are if there is some kind of logic flaw, somebody will notice it down the line before it even gets pushed to prod. And even if it is pushed to production or something like that, if the code is easy to read, somebody will notice it and notify you if not an attacker exploits it, and you'll figure it out pretty quick. And then also, note references to other code that's being used. So like, if you have an encryption library that you use, or a certain JavaScript dependency, whatever it might be, make sure that you're just noting references to those things and what version you implemented it at. And obviously the version is going to be wherever you're importing it, but just make sure that you're noting references to it and the purpose and the current understanding. So that way, if things change, or if other developers work on the project, they'll have a pretty good understanding of why it was used and what it's being used for. So with that being said, that's really all we've got to go over today. Pretty short one today, not that much to it, but we'll be back soon with another one in no time. So have a good one.